All right, hello and welcome back. So we're going to finish up these slides and then give you plenty of time to do any studying that you need to do for your midterm. So we stopped here. We learned how to throw our own exceptions and of course catch them. So the last few things that I want to talk about is like what's really going on under the hood when exceptions are getting thrown and caught. And then we'll give like a big final example. Okay, so let us get started with this. Let's talk about the exception handler stack. So I am going to have to make an example, I think. So I have made a blank file called exception_stack.cpp. And what I'll do is, well, let's make one function that will eventually throw an exception. I don't know, void do stuff. And it'll do things, it's like int x equals 5, x plus plus, whatever it needs to do, and then it'll throw an exception. Uh-oh. Oops. And if I want to use runtime errors, I need to include standard except. Okay, so this function is going to throw a runtime error, and in main, we can call it, and that'll be that. Of course, if we try running it now, it's not really going to work. It'll give us a runtime error. All right, so we have to try and catch the stuff, okay? Try to do stuff, and then stop and handle any exceptions that happen. Catch it by reference, I don't know, just e.what or something. Okay, so now we've got this going on. Oops, let's see, why is it unhappy? Did I not? Oh, I didn't save it, excuse me. There we go, so now it just prints uh-oh. And this is all well and good until fancier things start happening. Okay, so let me add some things here. Let's be like catch, I don't know, catch an int I. We know what to do with I. Maybe we can just print it out. Done. And then also, let's do this one. Before that, cout caught a runtime error in main. Caught an int in main. Let's do it up here too. Let's be like, okay, try to do all this stuff. Let's catch a runtime error. And also an int. Let's actually steal a lot of this. That's helpful. And we're not in main anymore, we are in do stuff. Okay, so this code is about to run. It's going to call do stuff. I want you to take your best guess as to what's going to get printed in this program. What do you think is going to happen? Main's going to run. I mean, this is the first thing that happens. It's going to call do stuff. What's going to go wrong? What's going to get printed out? Okay, because it might surprise you. So what's happening is it's catching the runtime error up here because we're handling it up here. It's catching it right after it's being thrown, and it's being caught right here, right after that. It skipped over this one. It did not even go straight to this one. And the question is why? Well, the answer is because this one was closer. This one was closer to the throw. Okay? And that brings us to the concept of exception handler stacks. All right? So just like function call stacks, we have exception handler stacks. So exceptions are really nice because you can catch them wherever you want in your code. Okay? You just stick a try somewhere, and then suddenly, no matter how deep in your code you are, no matter how many function calls you are between the try-catch block and the actual throw of the exception, it's going to jump right to there. Okay? And so C++, just like for function calls, it's building up a chain of things. It's building up a chain of exception handlers, catch blocks, the places where things get handled. And it knows which one to go to when there's a failure. It knows where the closest one is, and that's the one it thinks that you want. And so it's going to go straight there. Okay? So it's all very similar to the function call stack. C++ is keeping track of which try-catch blocks you're inside of. Okay? And that's how it figures out where to go. Okay? So it is a stack, and it starts from the top, and it goes from the top to the bottom to look for the first catch block that matches its type. So here's our stack, normal function call stack, where we called main, and then inside of main we called do stuff. That's only part of the story. Now, secretly, there's an exception handler stack. That's being built up. When we are right here, like line 7, 8, 9 of this code, we are both inside of this try-catch block and this try-catch block. See that? There's two of them. So this first one knows how to catch a runtime error and an int. Okay? So main knows how to catch a runtime error. Runtime error. So main knows how to catch a runtime error. Main knows how to catch an int. All these little catch blocks are being put on this little stack. And, okay, then also, though, we're inside of this function, too, because we called it. So then we know how to catch another runtime error and another int. See that? So do stuff also knows how to catch a runtime error. And do stuff also knows how to catch an int. So the second we are here on line 9, when something goes wrong, C++ looks at its exception handler stack, and it goes to the first one that matches. It just peels them off like an onion, like, okay, this one's not working, that's an int, I have a runtime error I need to handle. Bye-bye. Okay, this one tells me it knows how to handle a runtime error. I'm going to give control to this catch block. See that? That is the key. So it's going to choose this one when it's on line 9, and that runtime error gets thrown. This one is the closest matching handler. Okay, and that one is going to get control. So similarly, or maybe not so similarly, we could extend the try-catch blocks. Let's say this one down here, main knows how to catch a string. But let's see, caught a string in main s, and let's say that do stuff doesn't know how to catch a string. Okay, so you see what's going to happen on the exception handler stack? It's going to be like main knows how to catch this one, this one, and this one, a runtime error, an int, and a string. Do stuff knows how to catch a runtime error and an int, but not a string. So in case a string gets thrown, oh man, it's going down here to this catch block. You see that? It's always going to go to the first one, the closest one that can handle the correct type. Okay, so it goes all the way down to main to handle that. Okay, so yeah, that's the idea. So this one gets handled up here. And this one gets handled in main. It always goes to the closest matching catch block. Okay? And of course, this one is never going to execute if we throw this one first. So that is the idea of an exception handler stack, it's building up a list of all the things that it knows that it can handle, and it's going to the closest one. Okay, that's the idea, and it's got to match the type as well. So yeah, I think that's essentially it. The very last thing I want to show you is just coming full circle. I want to fix that original division example where things went wrong, and let's use exceptions. Let's throw a runtime error in the division function and just let whoever wants to handle that error. Okay, so I copied in our divide file from last time, and let's change this to have exceptions now. Oops. Let's make it throw a runtime error. If divisor is equal to 0, throw runtime error with like divide by 0. Yeah? And we can catch this. Okay? So right now it's just not going to work again. It's just going to end the program, but it's going to be a new kind of error. It's not a floating point whatever error. It's a runtime error. We're throwing it. Right? 42 and 0. See? Now it's a runtime error. And what is divide by 0? Okay, so we can change it now down here to actually handle the problem. So it's like, okay, let's try all of this. Let's try to do this stuff. Can probably just put it all in a try-catch block. That would help me for what I'm about to do. Catch a runtime error. This will totally work, but it's not quite what I want to do. And this is just a simple way of handling things, just to show you what we've been doing. It's like, oh, divide by 0. Cool. We scouted it, ended the program, we handled it, nothing went wrong. We can handle things in different ways. We don't just have to print things. We can like fix the program. We can make it repeatedly ask for a new divisor maybe. Wouldn't that be nice? So that is the idea. You can say bool did it work equals false. We're not sure yet. Did the division work? That'll keep track of that. And while it didn't work, while we're not sure yet that the division worked successfully, so while it's not true that it worked, then, if that's the case, we should keep trying to do all this stuff, right? We should keep trying to do all this stuff in here. Get the numbers, try to divide them, see if it actually worked. And we know it worked if we ever get past this line, because that means divide worked fine. We printed out the right answer, and we never got to this catch block, okay? If we get here, it worked. So, did it work? Should be true, and that'll actually stop this loop, okay? But if it never got here, if we threw an exception in divide, we jump straight to here without ever executing this line. We're going to jump straight to here, execute this line, say what, and we'll ask the user to try it again. Dot, dot, dot. Okay. So let's see if that works. That might do it. Whee. Two numbers to divide, 42, 0. Ah, let's try again. Nice. So 42 over 0 is divide by 0 because we break out of this right here. We don't actually finish the divide. So we jump straight to the catch block, output the what, which says, oh no, divide by 0. And then we say, let's try again. Okay. So then we're back here because did it work is still false. We come back and try catch all over again. All right, let's see if it works this time. 42, 0. Or I can give different numbers. 37, still 0. It's still divide by 0. So it's going to keep on staying in this loop until it can finally complete this line and therefore execute this next one. And that'll finally make this stop. All right, so 42, 2. Oh man, that one worked. So did it work? It becomes true after printing out the answer, and we get the result being 21, which is exactly what we wanted here. And this is a fancier way of using a try-catch block to do more than just printing things, but to like control the program, to make sure that we really do recover from our error, okay? That is the idea. So we need to eventually get to this line in order for the loop to stop, and therefore for the program to stop. Okay? And that means, if we got here, that means that we didn't throw an exception. Okay? So that is a more complicated example of handling things, and hopefully that is making it a bit more obvious as to why try-catch is so powerful. Okay? So you can just keep on doing the same thing over and over and over and over again while you keep throwing exceptions. Okay? That is the beauty of it all. Okay, so that is my last example for you, and one nice exercise for you, as much as you want to do it, is to add like exceptions, add exceptional cases, and checking for those to previous examples that I've given. Like, remember all those recursive functions that I wrote, and also the ones that you're writing in your lab? Those can all go wrong with perhaps a negative input, like what's the factorial of like -1, right? That is going to cause an infinite loop, because it's going to be like, okay, -1 times -2 times until I get to 0, which you never will. Yeah. So that's an exceptional case, and so maybe you should be throwing an exception there and letting the user hopefully handle the problem. Okay? So that is beautiful, and I guess the moral is the reason I'm encouraging you to take advantage of exceptions and try-catch blocks is that if you think about exceptions, if you do this and throw things in the right places and think about where is the right place, you're being forced to think about what could go wrong. And that's really good. It's called defensive programming. Like defensive driving, right? Defensive programming. Thinking about errors before they happen. And obviously that's a very good thing to be doing and to keep in your mind. All right, so that is all that I have for you for this set of slides. You have ample time now to go and study for your midterm, so good luck. Please yell at me if you have any questions, and I will see you later.